so I've got my foldable glued in over here. On the right hand side is where we're going to do our example, and it's going to take the whole page. So instead of doing two examples, one of the easier and one of the harder, I'm just going to go straight for the harder, and then your practice problem is actually going to be one of the easier ones. And by the way, here's my baby Charles. I brought him for you guys to see. He's getting a little anxious. We've been here for a while. Aren't you, baby? You want to do a little dance for these guys? You want to do a little dance for these guys? Oh, sexy lady. Oh, 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 oh. Yeah, he's not too into the dancing, but I hope you guys enjoyed that. So go ahead and sit down, baby. Sit down. It's okay. Sit. All right, so here is our example problem. Now that we've digressed, let's see. Let's get something hard out of the book here. Let's do sorry, I guess I should have had this ready in advance. I'm a bad teacher. Let's do y equals sine of x over 2 minus pi over 2. So before we even start, I'm just going to identify the things that have changed from the parent function. So first of all, we can see that the amplitude is just 1. So that's not going to change. And then I'm looking over here in my foldable. I also need to identify my period. And in my notes it says 2 pi over b. Well, what is my b here? It's not 2. Okay? What is being multiplied to my x? 1/2. So be careful about that. Okay? That's why I chose this problem, because our period is going to be divided by 1/2. And when you divide by a fraction, it's the same as multiplying. So we have 2 pi times 2 over 1. So our period is actually 4 pi. So is our period going to be smaller or bigger? Hopefully you guys realize it's bigger, actually twice as big. And then do we have a horizontal shift? Yes, we do. All right, and to calculate our horizontal shift, it says in my notes we do C divided by B. So here's my C. So we're going to do pi over 2 divided by 1/2. Notice I did not include the minus sign. Don't include this in C. It's kind of like when we learned in Algebra 2 last year, P and Q. You don't include the minus sign, okay? They lie or whatever. So 1/2 divided by 1, or pi over 2 divided by 1/2 is the same as pi over 2 times 2 over 1. So our horizontal shift is pi. We're going to scoot pi units in the positive direction. So now that we know all that, let's go ahead and identify our x values. Our starting x value is not going to be 0. It's going to be our horizontal shift, which is pi. So then pi or x sub 2 is going to be x sub 2 plus a quarter period. So up here I need to go back and find out what my quarter period is. I need to calculate that. 4 pi, that's my period, divided by 4 equals pi. So my quarter period is pi. So I'm going to add pi to pi and get 2 pi. X sub 3, I'm going to get 3 pi. Oh, this is easy. X sub 4, 4 pi. And x sub 5, 5 pi. And you notice my period was supposed to be 4 pi. How far do we go from starting point to ending point? 4 pi. So we know we're in the right direction. Now we need to find our corresponding y values. I'm just going to do those right over here. So that's step 3. So I'm going to find y sub 1. That equals sine and this is where it gets tricky. Okay, this is the trickiest part of the whole thing. You got to be careful when you're plugging in these x values. So we're going to plug in pi over 2 minus pi over 2. See, I just plugged in pi where x was at. So that's the same as sine of 0, which we know is 0. So y sub 1 is 0. Y sub 2. We're going to do sine of, plug in 2 pi. So 2 pi divided by 2 minus pi over 2. That's sine of pi over 2, which equals 1. If that is sticky for you, then you need to go back and look at where we learned about doing it by hand, or just memorize your parent function. And you know that sine of pi over 2 equals 1. Now we just keep on going. Sine of 3 pi over 2 minus pi over 2 equals sine of 2 pi over 2, which is pi, which equals 0, and just keep on going. Sine of y sub 4 equals sine of 4 pi over 2 minus pi over 2, which equals sine of 3 pi over 2, which equals negative 1. And lastly, y sub 5. If you guys are smart, then you'll know that, hey, that'll just be the same as my starting one, so I'm just going to write 0. Okay, these should always be equal. Now that we've got those, we can write our coordinates. So our coordinates for our graph are going to be pi comma 0, 2 pi comma 1, 3 pi comma 0, 4 pi comma negative 1, and 5 pi comma 0. Now I just have to graph those. So if we go down, got about a half a page left, we're going to create our graph. And remember, we have to extend the graph, so that's why I'm drawing the negative side also, even though none of our x values are negative. So I'm just going to plot pi right here and put 2 pi, 3 pi, 4 pi, 5 pi. This is my starting point. It's pi 0, and then our amplitude is 1. So I'm going to put y values 1 and negative 1, and then just plot my points. The trickiest part is calculating those y values. Now I've plotted my points, I'm going to sketch my graph with a smooth curve, and then extend the graph. And this doesn't have to be perfect, you guys, but it should look like it's repeating. Okay, and there, I've extended my graph, and we do know it's going to keep oscillating forever and ever and ever. So that's it. Now in your warm-up sheet, I'm going to have you guys do an easier practice problem because we're going to be practicing all day tomorrow. But here's the problem I want you to do in your warm-up. And yes, I will be looking at this, and this is going to be a big part of your points because we really only did one practice problem, so you need to do one. Let's do y equals 4 times sine of pi x. That's your practice problem. Good